Hello everyone, today we are looking at slope-intercept form of a line. You guys have already seen an equation in standard form. We used this when we were solving for intercepts. This was of the form ax plus by equals c. This is when we had the x and y on the same side of the equation and the constant by itself. In slope-intercept form, we're actually going to be solving for y. So slope-intercept form looks like y equals mx plus b, where m is the coefficient with x and b would be a constant term. When we're solved in this way, m will be our slope and b our y-intercept. So when we can solve to put this in slope-intercept form, it actually makes it really fast to graph. You guys have already solved equations for y and then have made a table to graph. Now we're going to learn a little shortcut to use our slope and y-intercept to do this. Let's start by looking at the equation y equals 3x plus 5. Since this equation is solved for y, it's considered to be in slope-intercept form. So straight from looking at this equation, we could see that our slope is 3 and our y-intercept is 5. So when we graph this line, we should be crossing through the y-axis at 5 with a steepness of positive 3. Let's see what this looks like. So let's make a coordinate plane here. We've got 1, 2, 3, 4, 5, make this a little bigger, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8. And to start to graph this, we can put a point straight on the y-intercept of 5, 1, 2, 3, 4, 5. And from this point, we can use that slope of 3 to count to our next point. A slope of 3 is the same as 3 over 1, so we can think of this as our rise over run. From our y-intercept of 5, we can count up 1, 2, 3, and over 1 to get to the next point. And we can continue this up 3 over 1 forever and ever and ever, and graph our line. Now yours will look much nicer on your graph paper, but I've started with the y-intercept and I've counted from that point to my next point using my slope. Let's try another one. This time we're looking at an equation in standard form. I'd like to write this in slope-intercept form and then graph the line. So to write in slope-intercept form, we're going to need to solve for y, get y by itself. We can start by subtracting 3x from both sides. And that leaves us with positive 5y equals 10 minus 3x, or we could write that as negative 3x plus 10. We usually like to have the x first in slope-intercept form. And then we can divide through every term by 5. So in slope-intercept form, our equation is y equals negative 3/5 x plus 10 divided by 5 is 2. We're now in slope-intercept form, and we can use this to graph. So that line again was y equals negative 3/5 x plus 2. Let's go ahead and graph this line. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Again, we're starting with the y-intercept. It's a positive 2, 1, 2 on the y-axis. And I'm going to count my slope. The slope is negative 3/5. That's my rise over run. So let's count in since our rise, we're thinking of that as negative, we'll count in the negative direction. 1, 2, 3, and then right 5. 1, 2, 3, 4, 5. So again, we went down 3 over 5. We have a negative slope, so we should see that before we even graph this line, our line should be going, we called it downhill in class, going downward as we look at the graph from left to right. We've got a negative slope. Let's look at something interesting here. Let's graph y equals negative 1/2 x plus 1 and y equals negative 1/2 x minus 2 on the same coordinate plane. Can you think of anything interesting that might happen here? Starting with negative 1/2 x plus 1, let's graph using our slope-intercept form. We're going to start at the y-intercept of 1 and count my slope. It's negative, so I'm going to count down 1 and right 2. Let's get another point here. Down 1, right 2. Make our line. Now let's count negative 1/2 x minus 2. So again, we'll start on the y-intercept of negative 2. I'm counting down 1, right 2, down 1, right 2. Interesting. What do you notice about these lines? They're parallel. Why are they parallel? What do you notice in the equations? Well, looks like we got slopes of negative 1/2 here. So what we could conclude from this is that a line, or more than one line with the same slope, are going to be parallel. So if I wanted to write the equation of another line parallel to these, I could really use any y-intercept. I could write a third line that would be parallel to this. As long as it has a slope of negative 1/2, I could have a y-intercept of minus 1,000, and it would still be parallel to these lines. Pretty cool, huh? Similarly, perpendicular lines, which means they make a right angle, have what are called opposite reciprocal slopes. Opposite reciprocal slopes. So what that means, if I have let's see, equation of a line, say y equals 3/5 x plus 2. And we want the equation of a line that's perpendicular to this. The perpendicular slope would be the opposite reciprocal, meaning reciprocal, I'm going to flip 3/5 to 5/3, and opposite, since 3/5 is positive, my opposite would be negative 5/3. So an equation of a line perpendicular to 3/5 x plus 2 will be any line with a slope of negative 5/3 x. We could use the same y-intercept. We could use a different y-intercept, minus 3, for example. Our lines will still cross at a right angle, meaning they're perpendicular. I hope that this intro video is helpful to slope-intercept form. We'll be exploring this in class this week. Please come to class prepared with any questions.